Hello, calculus fans. Okay, let's try to use the table of integrals to find the area under the curve y equals 4 minus x squared raised to the 3/2 power, and above the x-axis between 0 and 1. So the area that we're looking for is this integral from 0 to 1 of 4 minus x squared to the 3/2 power dx. And there's actually an entry in the table of integrals that will evaluate this for us. So if you want an antiderivative of a squared minus u squared to the 3/2 power du, it looks like negative u over 8 times 2u squared minus 5a squared times the square root of a squared minus u squared plus 3a to the 4th over 8 times arc sine of u over a plus c. Wow, what a mess. Okay, so we can use this. We're going to use a equals 2 and u equals x. Now we can just plug things in directly into this formula given. So this integral is just equal to that whole thing minus x over 8 times 2x squared minus 20 times square root of 4 minus x squared plus 6 arc sine x over 2. That's evaluated from 0 to 1. And you should sort of notice that we plugged in all the values of a so that we can actually have the thing to evaluate. Now the good news about what we see here is that if we plug in the lower limit, everything's going to be 0. Like if we plug in 0 there, that part's going to disappear. And here, arc sine of 0 is just 0. That's great. That means we only have to plug in the upper limit. And if we do that, we'll get this. And then this is not something you should leave behind because arc sine of 1/2 is something you should know. You should know that that's pi over 6. So here's our final answer, 9 root 3 over 4 plus pi. All right, so how about another bit of extra credit? How about trying to evaluate this without using the table of integrals, without using a computer system? Use an inverse trig substitution and see if you can get this answer here. Okay, that's all for now.